We're spending more time on simplifying trig expressions, and they're getting a little bit harder. So if you look at our first example, we have a fraction plus a fraction. So of course, anytime you add fractions, you need a common denominator. Looking at the two fractions we have, their denominators do not have any factors in common, so you simply multiply each fraction by the other denominator. So our first fraction will get multiplied by sine theta over sine theta. Remember, when you multiply an expression, you need to multiply by a form of 1 so that you're not changing the value of the expression. Our second fraction, we're going to multiply by 1 plus cosine theta over 1 plus cosine theta. Next, we'll multiply each of our fractions. So our first fraction, we have sine squared theta over, and I'm going to leave it in factored form, sine theta times 1 plus cosine theta. Our second fraction, we have cosine theta plus cosine squared theta over, again in factored form, sine theta times 1 plus cosine theta. Adding our fractions together, I'm going to rearrange because I see the sine squared plus cosine squared, and I recognize one of the Pythagorean identities, so I'm going to put those next to each other. And then we have our additional plus cosine theta all over sine theta times 1 plus cosine theta. So in the numerator, as I mentioned, we've got that Pythagorean identity, sine squared plus cosine squared equals 1. So we have 1 plus cosine theta in the numerator, and then leaving our denominator alone. Notice we have the 1 plus cosine thetas that cancel, leaving us with 1 over sine theta. And the reciprocal of sine is cosecant of theta. Again, we need a common denominator for this example, and again, they don't have anything in common, so we're going to multiply each of them by the other denominator. So this one is 1 minus cosine x over 1 minus cosine x. We'll multiply our second fraction by 1 plus cosine x over 1 plus cosine x. In the numerator, multiplying by 1 doesn't change anything, so our first fraction we have 1 minus cosine x. In the denominator we have conjugates, so we get to shortcut this one instead of foiling. We've got the 1 times 1, and then the negative cosine x times positive cosine x is negative cosine squared x, plus, very similar on the second one, we've got 1 plus cosine x in the numerator over 1 minus cosine squared in the denominator. Adding our fractions together, our negative cosine x and positive cosine x in the numerator cancel, leaving us with 1 plus 1, which is 2, over 1 minus cosine squared x. This looks like it might be as much as we can do with this one, because we've got that 1 minus cosine squared in the denominator, and we can't use the reciprocal identity on that because it's not just the cosine. However, it is one of the Pythagorean identities. Sine squared plus cosine squared equals 1, so when you rearrange that, 1 minus cosine squared is sine squared, and the reciprocal of sine squared is cosecant squared. Example 3, instead of having a denominator, we have a binomial squared. So think about, what does it mean to square something? It's really tempting to just distribute the square into the parentheses, but you'll be missing the middle term, the O and the I, when you FOIL. So write it out the long way, sine x plus cosine x times itself, sine x plus cosine x. And as I mentioned, we're going to be foiling. So sine times sine is sine squared plus sine times cosine We'll have that again, the cosine times sine. I'm going to write it in the same order so it's more obvious we have like terms. Plus, then we have the cosine times cosine, which gives us cosine squared. Rearranging this a little bit, I'm going to put my sine squared plus cosine squared together because that's our Pythagorean identity. And then we have sine times cosine plus sine times cosine, which is 2 sine of x cosine of x. Sine squared plus cosine squared is 1. So we have 1 plus 2 sine x cosine x. This one can't be simplified any further, so we're done.